Hi everyone. Today we're going to study integration by substitution. Specifically, integration by substitution method helps us find antiderivatives when the integrand is the result of a chain rule derivative. Here are the steps. Step 1. Look carefully at the integrand and select an expression g of x within the integrand to set equal to a variable u. Let's select g of x such that g prime of x is also part of the integrand. Step 2. Substitute u equals g of x and du equals g prime of x dx into the integral. Step 3. Evaluate the integral in terms of u. Step 4. Write the result in terms of x and the expression g of x. This is example 1. Use substitution to find the antiderivative of the integral 6x times the quantity 3x squared plus 4 raised to 4 dx. For our solution, step 1 is to select u. Let us select this 3x squared plus 4 as the u. And let us take the derivative of this expression. So we have du equals 6x dx. If we analyze the integrand, the 6x and dx here is the value of du. And we say that this du is in the integrand already. Step 2. Substitute u and du in the integral. So we have now this 3x squared plus 4 is the u, and this is raised to 4, and the 6x and the dx are equal to the du. And step 3 is to evaluate the integral in terms of u. We're going to use the power rule, so we have now the u raised to 5 over 5 plus c. Now the step 4, to write the result in terms of x and the expression g of x. It means we're going to return the value of u from here. So we have now this 3x squared plus 4, the quantity is raised to 5 all over 5 plus c. This is the final answer. Example 2. Use substitution to find the antiderivative of the integral of z times the square root of the quantity z squared minus 5 dz. For our solution, let us rewrite the integral showing that this radical is in the form of fractional exponent. So we have now the integral of z times the quantity z squared minus 5 is now raised to 1/2, then dz. And from here, let us do step 1 to select u. We're going to select the quantity z squared minus 5 as the u. And then let us take the derivative of both sides. So we have du equals 2z dz. Now considering the integrand, we have here the z dz, but the value of du equals 2z dz. This constant 2 on the right side we're going to eliminate by dividing this equation by 2. So we have now du over 2 equals z dz. Step 2. Let us now substitute the values that we found in step 1. So we have now the integral of this quantity z squared minus 5, that is the u, and then raised to the exponent 1/2, and this z, dz, is equal to du over 2. So we copy it here. Now this denominator 2 is a constant that we can put it outside the integral sign. So we have now 1/2 times the integral of u raised to 1/2 du. And we can do step 3 to evaluate the integral. Let us use the power rule in here. So we have the constant 1/2 times u raised to 1/2 plus 1 all over 1/2 plus 1. The 1/2 plus 1 is equal to 3 over 2. So we will write now 1/2 times u raised to 3 over 2 all over 3 over 2. Let us simplify the denominator 3 over 2 by flipping it up, thus making this denominator 2 here to be the coefficient of u in the numerator. So we have 1/2 times 2 u raised to 3 over 2 over 3. We can cancel the 2 and the 2. So we simplify our answer into u raised to 3 over 2 over 3. Then we write plus c. And step 4, write the result in terms of x and the expression g of x. So the value of u from step 1 is the z squared minus 5, and then this is now raised to 3 over 2 all over 3 plus c. This is now the final answer. Example 1. Evaluate the integral of sine t over cosine cube of t dt by substitution. For our solution, the step 1 is to select the u. Take note that this cosine cube of t is the same with cosine t, and the quantity is cubed. And from here, let us choose the cosine t to be the u. So we have the cosine t here. Then let us take the derivative of this equation. So du equals negative sine t dt. Analyzing our integral here, we have the remaining function to be sine t dt, which is positive. So what we're going to do here is to multiply this equation by negative 1. So we have now the left side to be negative du equals the right side is now positive sine t dt. Step 2, let us substitute the values of step 1 to our integral. So we have this cosine t to be u, and we can see the power 3. And in our numerator, the sine t dt is now replaced by negative du. Step 3, let us evaluate now the integral. First, let us move the negative sign outside the integral. Also, let us show this u cube in the numerator with a negative exponent. So we have now negative integral of u raised to negative 3 du. Now let us use the power rule to evaluate this integral. We have now the negative of u raised to negative 3 plus 1 over negative 3 plus 1. Negative 3 plus 1 is simply negative 2. So we have the negative of u raised to negative 2 all over negative 2. The negative sign of the fraction and the negative sign of the denominator will neutralize each other, so it becomes positive. And then, let us now rationalize the numerator with a negative power, so we have now 1 over 2u squared. And then, we write the plus c. Step 4, let us now return the value of u from step 1. So we have the 1 over 2 cosine square of t plus c. This is now the final answer. Example 2. Use substitution to find the antiderivative of the integral of 3x squared times e raised to 2x cubed dx. For our solution, let us select u. In this problem, we're going to choose u with that of the exponent of the e, the 2x cubed, and we write it here. Then taking the derivative of this equation, we have now du equals 6x squared dx. Observing our remaining function 3x squared dx. But the value here is 6x squared dx. We want to show this right side to be the same with our remaining function in the integrand. So we will divide this by 2. So the left side now of the equation becomes du over 2 equals 3x squared dx. Now step 2, let us substitute the values of step 1 to our integral. So we have now the integral of this e, then raised to the u now, times this 3x squared dx is replaced by du over 2. Then step 3, let us evaluate the integral. First, this denominator 2 is a constant, so let us move it outside the integral. And that is now 1/2 of the integral of eu du. This integral of eu is equal to eu itself. So we have now 1/2 times e raised to u plus the c. Now, step 4, let us return the value of the u. So we have 1/2 times e raised to 2x cubed, then plus c. This is the final answer. Example 3. Use substitution to find the antiderivative of the integral dx over x minus 5. Step 1, let us select u, and this time we're going to select the denominator x minus 5. And then let us take the derivative of this equation. So du equals dx. Step 2, let us now substitute the values of step 1 to our integral. So the integral of this dx now becomes du over the x minus 5 becomes u. Then let us evaluate the integral. So we have the integral of du over u is simply the ln of the absolute value of u, then plus c. For step 4, let us now return the value of u from step 1. So the u is the x minus 5. So we write now ln of the absolute value of the quantity x minus 5, then plus c. This is the final answer. In the succeeding examples, let us see a slightly different method. So this is example 4. Evaluate the integral of 2x plus 5 times x squared plus 5x that is raised to 7 dx using substitution method. Step 1 is to select u. We have here two functions. The bigger functions, or that function with a higher degree, gives us clue that it must be the u. So x squared plus 5x is our u. We don't write the power 7 yet. So u is this x squared plus 5x. Then we take the derivative of this u with respect to x. So du over dx equals x squared becomes 2x plus derivative of 5x is 5. Now we want the value of dx. We exchange positions for dx and the right side values 2x plus 5. So it becomes like this. Dx equals du over 2x plus 5. Step 2. We substitute for u and dx to the original problem. So these are the values of u and dx. The problem now becomes the integral of the 2x plus 5 we copy here times this is our u raised to power 7. And the value of dx, the du over 2x plus 5. Then we simplify. We can cancel the 2x plus 5 and 2x plus 5 respectively. Upon cancellation, everything about x is removed. Only u and du are here. So, integral of u raised to 7 du. Then step 3, let us now evaluate. By power rule, we have u raised to 8 all over 8 plus c. Then step 4, we replace the x value of u. This u is x squared plus 5x, so we have now x squared plus 5x that is raised to power 8 all over 8 plus c. This is now the answer. Example 5. Evaluate the integral of the square root of the quantity 7x plus 9 then dx using substitution method. Let us select u. In here, we only see one function, the 7x plus 9 that is inside the radical sign. So when we select u, we will take only the 7x plus 9. Then we will take the derivative du over dx that is equal to 7. And we want to get the value of dx. We cross multiply, or we say we change the position of dx and the value 7. So dx equals du over 7. Then step 2. We substitute for u and dx. In our original problem, it becomes like this. The integral of the square root of, this is the u, times the dx. And the value is du over 7. We can simplify this by moving the constant outside the integral sign. So it becomes 1 over 7 times the integral of the square root of u du. Then let us evaluate. This integral sign we can write as fractional exponent. So u raised to 1/2. Then by power rule, we have now u raised to 3 over 2 all over 3 over 2. The constant 1 over 7 is here. Then we add the constant of integration plus c. 3 over 2 down here, we're going to simplify. We flip it into here becomes 2 over 3. So it becomes like this. And step 4, we replace the x value of u. This is our u value. Then we simplify our answer. The fractions we multiply. 1 times 2 is 2. 7 times 3 is 21. The u now becomes 7x plus 9. The quantity is raised to 3 over 2 plus c. Example 6. Evaluate the integral of 3x squared plus 4 times the function sine of the quantity x cubed plus 4x plus 5, then dx, using substitution method. First, we select u. There are two functions here. One is a polynomial function and another is a sine function. But for the sine function, the angle here is a polynomial with a degree that is higher than the first function here. In that case, our u is the angle of the sine, so the x cubed plus 4x plus 5. Then we take the derivative of this. So du over dx equals derivative of x cubed, 3x squared. Derivative of plus 4x plus 4. Derivative of plus 5 is 0. And then we want the value of dx. This dx comes to the right side, and the right side value comes as denominator. So dx equals du over 3x squared plus 4. Again, we say that the u and dx are important because in step 2, we're going to substitute for u and dx to the original problem. So we have the integral of this 3x squared plus 4 times the sine of this quantity that becomes u. Then the dx we change now by du over 3x squared plus 4. And from here we simplify by doing cancellation. The 3x squared plus 4 is cancelled with the 3x squared plus 4 in this denominator. We can see that our problem now is reduced to u and du. So the integral of sine u du. Then step 3, let us now evaluate. We have the integral of sine u du as the negative cosine u plus c. Then we replace the x value of u. This is our u value with respect to x. So we have negative cosine of the quantity x cubed plus 4x plus 5. Then plus c. Example 7. Evaluate the integral of 2 over x times the square of ln x, then dx, using substitution method. Let us select u. Because of this power 2 here, we now conclude that our ln x is our u. So, u equals ln x. Then we take the derivative. Du over dx equals derivative of ln x is 1 over x. And here we want the dx. We cross multiply. Dx multiplied to 1 and this x multiplied to du. So dx equals x times du. So values of u and dx are important. Step 2. Let us substitute for u and dx in the original problem. So we have the integral of 2 over x times ln x is now u with the square times the dx. We now change into x du. Let us simplify. We can cancel the x and the x down here. And then let us write again our problem. The constant 2 we can write outside of the integral. So 2 times the integral of u squared du. There is no more x in our function here. Then step 3. Let us evaluate. By power rule, u squared becomes u power 3 all over 3. We copy the constant 2 and then plus c. Step 4. We replace the x value of u, and that is ln x. So finally, it is 2 times the cube of ln x all over 3 plus c.